Okay, let's look at some more applications. So we've done a little bit with applications already. So example 7 says, when light passes through water, its intensity I decreases according to the formula I of x equals I initial times e to the negative 0.2x, where I initial is the initial intensity of the light and x is the depth in feet. If I initial is going to be 500 lumens per square meter, determine the depth x at which the intensity is 1% of the initial intensity. Okay, so when I'm working with application problems, if they give me a formula like this, the first thing I do is I write the formula down, and then I just make little notes about what everything equals. So I of x is going to be the intensity. I naught, or I initial, is going to be that initial intensity. And x is going to be what? The depth in feet. So I got all of that information from the first sentence where they introduce the equation. Usually it's very close to where they introduce the equation, right? Then I go down and go, okay, now what am I given? I'm given that I naught equals 500. So I'm going to replace this initial intensity number with 500. I'm also saying, what is x? Because it says determine the depth. So I don't know x. So eventually I'm going to have to solve for x. But it does tell me something about the intensity. It's 1% of the initial intensity. Well, I know the initial intensity, it's 50, right? I'm sorry, 500, right? So what is 1% of 500? It's going to be 5. My intensity that I'm looking at is going to be 5. My initial intensity is going to be 500. And I need to solve for x. So I see that x is part of the exponent, so that means I'm going to have to use log to solve this eventually. But first I have to isolate the exponent part. So my first step is to divide both sides by 500. So 5 divided by 500, I get a terminating decimal. So I can write that exact answer down. So I'm going to go ahead and replace that with 0.01. So since I have an e here, I'm going to take the natural log of both sides. You could do what? You could bring this exponent down in front. So we'll bring down that negative 0.2x in front of the natural log of e. But what is the natural log of e? That's just equal to 1. So now I have the natural log of 0.01 is equal to negative 0.2x. Divide both sides by negative 0.2. That leaves me with x on the right. So if I substitute this into my calculator, I'm going to get about 23.03. So what does that answer mean? That means that if the initial intensity is 500 lumens per square meter, then after about 23 feet, the intensity decreases to 5 lumens per square meter. So the percentage of Brazil's population that lives in urban areas can be modeled by U of x equals 72 plus 4.33 natural log of x, where x is greater than or equal to 1 is the number of years after 1990. Evaluate U of 24 and interpret the results. Again, it might be useful to write your equation down and make little notes about what everything equals. So this U of x is going to be the percentage of Brazil's population that lives in urban areas. So I just put percent of population in urban areas. Our x is going to be what? The number of years after 1990. So if I want to evaluate U of 24, I'm going to substitute 24 in for x. And then I'm going to put this right side into my calculator. So I got about 86. Is that what you guys got? There aren't any rounding rules given in the problem. So if you put 85.8, that would have been okay too. And so now let's interpret this. So first we have to deal with this 24. That's the number of years after 1990. So 24 years after 1990 is 2014. So in 2014, about 86% of Brazil's population lived in urban areas. So what if we wanted to predict when urbanization will first reach 88%? So again, my little notes on my equation might help. 88% is given. Well, this is the percent of the population. So that means I need to replace U of X with 88%. I need to solve for X. So this is a log, so that means I need to isolate this logarithm before I do anything else. So my first step, I'm going to subtract 72 from both sides. So 88 minus 72, that's going to give me 16 equals. My 72s on the right reduce to 0 or cancel, and then I'm left with 4.33 times the natural log of X. So I want to get the natural log of X by itself, so I'm going to divide both sides by 4.33. I went ahead and then exponentiated both sides, and I used the base E because I'm dealing with natural log, which is log base E. So this right side is just going to simplify to X. The left side, I'm going to put into my calculator. So E to the 16 divided by 4.33, 40.25161452. Again, there aren't any rounding instructions, so 40, 40.2. Since we're dealing with years, I just went ahead and rounded to 40. And so now we need to interpret this. So X equals 40. Well, X is the number of years after 1990. So 40 years after 1990 is 2030. So in 2030, about 88% of Brazil's population will live in urban areas. Example 9, the half-life of tritium is 12 years. Tritium, not sure exactly how to pronounce that. We're going to go with tritium. The half-life of tritium is 12 years. If the initial amount is 15 grams, then the amount of tritium after X years can be found by T of X equals 15 times 1/2 raised to the X divided by 12. How much time does it take for the amount of tritium to decay to 5 grams? So again, I'm going to start with writing my formula down and do a little bit of labeling. So the amount, so this is going to be the amount after X years. And this is going to be time in years. So how much time, so I'm going to be looking for X, does it take for the amount of tritium to decay to 5 grams? So I'm going to replace this with a 5. So my first step here is to isolate this exponential. So I'm going to divide both sides by 15. So all I did was just divide both sides by 15. So 5 divided by 15 is a third. So a third equals 1/2 raised to the X divided by 12. So because the variable's in the exponent, I'm going to take the log of both sides. Now I can use my exponent rule to take this X divided by 12 and bring it out in front. So I want to isolate this X, at least it's out of the exponent. So that helps me. So I started by getting rid of this log of 1/2 because this is just a number. So I'm going to divide both sides by log of 1/2. So if I divide both sides by log of 1/2, that means they're going to cancel on the right and I just have X over 12 left. So on the left side, I still have my log of 1/3 but now I'm going to divide that by the log of 1/2. My very last step is I'm going to multiply both sides by 12 because I want to get rid of this 12, and I'm dividing by 12. So the opposite of that is multiply by 12. So this is a pretty big expression to put in my calculator. But if I do, I get about 19.02. So 15 grams of tritium will decay to 5 grams after about 19 years.